This is the Group G digital electronics project. We had to design a device to measure the frequency of a ruler. We started by having a start button to trigger a monostable for 1 second, which is then fed into a AND gate made by 2 NANDs. The output of the other input of the NAND is decided by this infrared beam sensor, which works when the beam is broken. It goes low, otherwise high, which is then amplified by this op amp to 5 volts. And if we can just show this is demonstrating it going high to low. So when both the monostable and the sensor output from the op amp are high, it is then fed to a ripple counter, which then counts upwards and holds it, which is then sent to an Arduino to decode it and to the LCD screen.
This is the infrared LED and phototransistor section of our project. We designed the apparatus so we wouldn't use the table, and there's a ditch in between these 2 platforms to leave space for the ruler to oscillate. Each time the ruler breaks, the path between the infrared light and the phototransistor, a low is given, and we use the infrared phototransistor outputs a constant current, and we use a high resistor of 220 kilo ohms to output a voltage of 1 volt.
So to count the hertz, we just use a 4040 ripple counter, and it was a good idea to use this because it's a common chip, and as well the fact that it's a ripple counter, built inside this chip, we can use it to divide the actual number counted, because the frequency is cycles per second, and a cycle has 2 peaks at the top of the crest of the wave, so we need to divide that number to 2. So we did that by using the Q2 output as our first binary bit, and I don't know if you can see that in the video, but so also built in is reset, so we use this reset button here to change the frequency back to 0 and to start measuring again, or else if you don't have to, we can just sum up frequencies of different waves. And so the outputs, we use Q2 to Q7, which is 6 outputs, and they go fed into Arduino, which decodes them into the decimal number, which Jack will talk about.
Right, so as Kevin was talking about, all these white wires from his ripple counter are going into various input pins. What I've done in the code is I've created a 6-bit array where each bit is 0, and whether or not the input pins are receiving high, if they are, they'll convert the 0 to a 1, giving you a 6-bit binary number. And if I scroll down here you'll find the code that will cycle through each of these bits, and if the bit is equal to 1, it will convert that to the relevant number and add them all together to convert the whole string of bits into a decimal number, and then print it on the LCD screen, which is set up in the standard way that you can find on the website.